GCP community meetup. I'll spend a few minutes just to give you intro about what we are generally doing. So we created this community as a place that should be kind of fun, safe place where we can share all of our tech ideas, to explore tech, to share experience, and to learn from each other, basically, and to basically build on these ideas further. Typically, how do we work here? We have typically technical meetups where either on-site meetups or online meetups, we meet on regular basis, and we bring relevant GCP topics for the Benelux region. One of our goals is basically to create the expert network that collaborate and share technical knowledge among each other. Just a few really basic housekeeping rules for today. So yeah, this is public area, so feel free to take photos. You can post photos to social media. These are nice things. In case you need a restroom, feel free to leave the room with minimal interruption of the session, and restroom is just back and right and right. We will need to leave this building at 20:45, and these are security rules, so we will follow those rules. We are really trying to create inclusive events that everyone will enjoy. So if there is anything that you see that might not be in good order, just reach out to Googlers. You can recognize Googlers by raising hands or by sharing this logo. So yeah, these are, I would say, a few important things for a person in this room. For our online guests, this event will be a bit less interactive, so I would kindly ask you to keep your microphones on mute during the entire meetup, so we ensure that meetup can has a flow as planned. In case you have questions, feel free to use the form that we shared in the calendar invite for today's session. And also, do not post your questions in the chat of Meet, because we are not going to read that. So I would say chats we might use only for some kind of, let's say, emergency things, like you cannot hear us or something like that. So let's use it just for technical informations. So yeah, have fun today, and yeah, find our community on the social medias as well. I will now leave the podium to the OriginTrail host. Awesome.
Thank you very much, Brian, and all the Googlers for having us, and to everybody who came to the meetup. I've just realized that there's a bunch of people who flew in, so it's incredible to have you guys. Thanks so much, and yeah, it's we hope that we justify your expectations. I think you guys should join me here. Maybe wave at everybody on the screen and say hi in a few words before we start.
I just wanted to say no problem. I flew in. It's fine. It's fine.
Yeah. So maybe it's people making here. It's only fair to introduce ourselves first and say what we'll be talking about today. I guess I'll keep admitting people all the time. So the four people in front of you are only part of the team, or rather the community behind OriginTrail. Together we be from my right to left is Riga, one of our co-founders, Tomasz, also co-founder, Yuri, our general manager, and myself, Vladimir, I'm also co-founder and CTO. And today we'll be presenting pretty much a lot of stuff about OriginTrail, including the vision for Verifiable Internet. So how that all fits in together with the modern explosion in AI. We'll also show where OriginTrail is already implemented, how major companies are using it, but we won't go too let's say too far into the use cases. We'll actually show you how you can use the technology to build something with it. So we have a bunch of demos, and we also have a colleague from the team joining also to give kind of a very exciting knowledge mining demo that you'll see, which probably you don't know right now what that means, but we'll pretty quickly introduce it. And yeah, last but definitely not least, we have a very special guest today, our long-term advisor, Dr. Bob Metcalfe, who you can see on the screen over there, waiting right now, who will be joining us. We thought only for the panel, but we're super happy to have you, Professor. And perhaps you can just say hi, and we can make sure that your sound works if you unmute yourself. If you could hear me.
I am not muted now. Is that
Perfect.
right?
We can hear you. Hello, Professor. Good morning over there in Texas, I believe, right?
I'm in Austin, Texas, but I've tricked you. I'm not here to teach. I'm here to learn.
Fantastic. Well, we hope you get to learn something, and it's a very big privilege to be able to hear something like that from a person like you and to be advised by you. So thanks again for joining us. And yeah, we'll be talking with kind of a final panel at the end with Professor about what he sees as the future of AI. If you don't know who that person is you should read up, because basically what we're doing here today, without Professor Bob Metcalfe, he literally invented Ethernet. Was one of the main pioneers of Internet, the stack. If you're very precise, that's the lower layers of the stack, the most foundational layers on the OSI 7-layer stack, right? You go on literally the first two, and also famous for the very, very famous Metcalfe law, which actually explains how value of a network can be computed. So we'll talk about that today. So yeah, I guess without further ado, we're kind of on 7 minutes in. We can, I guess, get started with the presentation. Everybody all right?
Yeah.
Start? Awesome. Cool. All right. Anybody want to hop in at the beginning? I guess the clicker works. Let's see.
You're the closest.
I have to get him plug me. So yeah. So okay, we have an agenda to start with. So I guess anybody want to leave the agenda, because I'll be speaking for an hour.
Your throat doesn't get dry. So we have. Okay.
Go ahead.
Yeah. Okay. Good. So we have 5, let's say, or 6 high-level agenda points. We're going to talk about why verifiable internet for AI is important. Show you a couple of examples, really cool ones. One of them being the Swiss Federal Railways, how we use verifiable internet and AI to kind of maintain the safety of trains and railways in Switzerland. Then a quick introduction into what OriginTrail decentralized knowledge graph is, how we can build actually something called Paranets. We'll introduce this concept during the presentation as well, something really exciting, and how we can actually build using various different Google GCP tools and AI models. And then we'll have the panel with Bob, together with Lana and Simon. Oh yeah, and then we'll have a round of networking, some drinks, some food, and then we also have some additional things that we won't show through the presentation that you can play around with. So, somebody sneezed. Bless you.
Can we please ask everybody to mute themselves on the call?
Yes, please do that.
Okay, more people. I guess. Okay, you're muted.
So, Rakesh Patel, please, if you could.
It's done.
Is that okay?
Awesome.
Okay, cool. We got a one shot. Okay.
Awesome.
All right, that's the agenda, I guess, and then hand it over to.
Still coming in, right? Yes. Okay.
Yeah.
Cool. Okay. Yeah. So we actually wanted to. No need to click. Okay. Yeah. Thanks. Sorry. We wanted to start actually by a quote with Dr. Bob Metcalfe actually talking about the problem of connectivity, the benefits of connectivity, but also the problems that can come out of it. And I guess you can read it on the screen, but I can also read it for you. And essentially establishing that in a time of abundant connectivity, there is also abundant misinformation, so that one of the evolving tools, the OriginTrail decentralized knowledge graph, which we'll be showing today, actually helps you find the truth in knowledge. In particular, knowledge graphs improving fidelity of artificial intelligence. So we'll show that today, and we can dive deeper very quickly. So,
I guess we can.
you guys want to take a sip?
I said
Like this.
I said something.
You said something, right? Yeah, somehow it turned out that I'm speaking most of the time, but that's not a problem because actually,
Just pull me up if you need.
yeah. So we're going to actually explain this idea, but like this, normally what we do is we dive into the deck and like explain there's this and that. And this time we're going to want to do it a little bit of another way. So, so going from the user, as we mentioned, the Swiss Railway Company, RiseDB. So essentially, Swiss Railways, or these guys here, I guess you can see that. Yeah, that's their logo. They've been using OriginTrail for the past 4.5 years to actually track all kinds of things within their rail network and supply chain. And they've been using the technology, this OriginTrail decentralized knowledge graph, to actually essentially assemble all this information in one place from all of the partners within the rail network, including partners from adjacent countries such as Deutsche Bahn, Swiss Railways, French Railways, which is the SNCF. If you don't know about this logo, and OBB is the Austria. Thank you very much, sir. That's most kind of you. So essentially, collecting information that's disparate across different railways, countries, industries, and so on. And why they're doing it is essentially to increase safety. They're right now at this moment, they're the most safe, essentially the most safe railway in Europe, and it's essentially one of the most transparent ones. So you can actually go and check on the website all of the different KPIs in terms of what they've actually achieved when it comes to safety in the previous years. So where does this safety come from? Comes from actually all of this visibility, but also for verifiability. So the ability to actually trust the information you're seeing. So there's a lot of interesting stuff in the infrastructure, such as sensors on locations, different locations across the rail network that track how trains pass over, what's the weight of the trains, what's the time, the temperature, all kinds of things. They also track what happens with the tracks, especially what they're trying to figure out is where tracks break. Because when train tracks break, then, well, all hell can break loose, right? So essentially the point here is that if that happens, hopefully it doesn't. But with a large network and so many tracks, statistics just says that over time, if you don't do anything, it's bound to happen, probability grows to 1, right? So what they do is they try to track even maintenance events. So when was the last time they checked certain rail weldings where they actually welded together? But not just checked, but also with what they were welded together, which tool, what was the temperature, what was the person. They're trying to go as deep as possible and actually use that to predict. So when they figure out that something was broken, how can they make this connection with what was the kind of the common denominator? So for them, predictive AI, Gen AI, and knowledge graphs are extremely interesting because if they manage to find or rather optimize where to look for, they actually learn to, they save lives. So it's simple as that. So a very simple demo is what to start with, and today is they have actually, so I should have it here. So this is one of the interfaces they're using, nothing extremely special. This is a table where they can go through all of these supply chain events. They can essentially view them. These are something called EPCS events. I won't take you too deep there, but this GS1, this organization, you know about them, even though you don't know about them, because they're basically the inventor of the barcode. So whenever you've seen a barcode, you've seen a GS1 identifier. Well, we don't put barcodes on trains, but we put something like this. So we put these GLNs, which are basically locations, and we put these GAIs, which are basically global unique identifiers. Should I pause?
You can just continue. I'll try to
Okay. Awesome. So it's the point of this file is not to go deep. What I'm just showing you is basically the information on how we can track this in a standardized way. And essentially what they do on a daily basis is they do a lot of data processing on these checks, such as is it BS1 compliant or not, and so on. Essentially tracking their whole supply chain for many years now. But when they want to actually go into other repositories, they use this decentralized approach. So they will actually go and create certain queries that happen on the repositories of others, such as the French railways, and open up their repositories to basically querying for certain information. Now we can imagine that obviously not all of this information is shareable with everybody, so they have certain levels of access control and so on. And in this case, this is like a very simple interface, and it's just one type of application that can be built on OriginTrail. But one of the things that we're working on right now is how can you actually do this through basically an interface like this. So you can come in, instead of like, going into these XMLs, which are a little bit old school, and like doing it a little bit old school way to a table, you can actually go ahead and ask the question. For example, what were the supply chain events for this object with this globally unique identifier GIAI, which is here. So if what actually I'm showing you now, it looks a lot like I asked ChatGPT something, but actually I didn't. So what happened is kind of a special kind of RAC. Well, maybe it's a good moment to ask the question, who here has heard of the acronym RAC? By a raise of hands? Okay, that's actually quite a few people. Awesome. So I'll explain for everybody else because that's still the majority. RAG is something short for retrieval augmented generation. If I were to simplify it to like most simple form, is like that instead of asking, let's say, an LLM, OpenAI, ChatGPT, Gemini, whatever, if you ask it something and it gives you a response from its knowledge, you actually feed it the knowledge first. You tell it, okay, take this document or book or whatever knowledge piece that you have, and you can say, take it, and then based on what I gave you, based on this knowledge, actually give me an answer. So, and you can then, okay, tell it to maybe formulate the answer a little nicer, like wrap it up in some way. But essentially, this is what happened here. So what we did is we asked it about events for this globally unique identifier. And well, you can pretty much imagine that none of the LLMs were trained on this because this was an event that happened 2 days ago. So not only didn't they have time, they also didn't have access. So of course, that's where RAG makes a lot of sense. You basically, that's kind of the killer app that everybody seems to be wanting now in terms of enterprise AI usage, because the key thing here is you don't actually get to the point where the LLM can hallucinate. So, or you significantly diminish this capability of the LLM to hallucinate. I deliberately say capability because many people would say, well, LLMs had bugs and they hallucinate. Like, well, in a way, you could say that's all they do. So that's kind of a feature rather than a bug. And in that sense, if imagine using that for Swiss Railways and you want to have some form of safety, you wouldn't necessarily use only an LLM. So today, we'll actually show you how to build something like this and actually what's going on in the hood, where you actually eliminate this problem by using the proper verifiable knowledge from the Swiss supply chain. And like I said, there's this answer where we basically see these events. It's nothing like especially human readable in this case. I mean, it is human readable, but not for regular humans who don't understand this standard. But what I can actually do is I can show you how this looks like under the hood. So what it looks like on the OriginTrail DQG. And before I do that, let me just check one more thing. Yes, I wanted to ask another question. So I have it somewhere here noted. So this would be a simple question, like, for example, what are the events? But I can also ask, let's say, list events obtaining weldings that were not tempered properly. So this is another type of question. It's not like I know what I'm looking for. Rather, this I don't know what I'm looking for, but I know that something wasn't checked or tempered properly. And actually, what happens under the hood, which I'm finally going to explain now, is it actually goes. Okay, I have a problem patching this. Actually goes into the decentralized knowledge graph to catch the data. So it reads this thing called the knowledge asset, which I'll also explain a bit deeper into the presentation. And it fetches it, here it is, fetches it from the DKG, and actually it has this graph structure. DKG Explorer is a tool where you can actually explore this. It's very much like a blockchain explorer, if you ever ran into one, such as Etherscan or similar ones. And the DKG stands here for the decentralized knowledge graph. So we'll see that also in a bit. What we're actually looking here at is this event. So essentially what this interface did is nothing extremely special. It went into the DKG, found the right information. It knew the list of sources it should take into consideration. And then it basically pulled this out and gave it to the LLM. So this graph here fed to the LLM. The LLM has basically very nicely annotated standardized data. And then with this, it's able to give you a response that's based on this type of graph. By the way, these knowledge assets, they also have, so I'll explain more in terms of how they're implemented, but they actually live on 2 layers. So they live on, part of them lives in the DKG and part of them lives on the blockchain, actually blockchain of choice, which actually gives it some very interesting verifiability properties. But before I run through everything right away, I'll go back to the presentation and continue actually explaining that with a little nicer type of slides. So, okay, I guess that was a kind of a first intro on how and why actually Swiss Railway is doing it. So for them, it's incredibly important that they have verifiable, trusted information that comes from various different parties inherently because of the way their network works, and that can actually easily access it and explore it. So they're not the only company using OriginTrail, obviously. So a couple more examples. For example, this first one called Factory that actually US retailers that are together part of this association called SCAN, which is basically Walmart, Target, Home Depot, Disney, I don't know, a bunch of them, I don't digit number, who together with British Standards Institution basically employ OriginTrail to exchange something called security audits. These are essentially documents on auditing factories abroad, mostly in China, for things like child labor, for generally sustainability practices and so on. And it's interesting because they're competitors, right? You have Walmart who competes with Home Depot, why would they work together? Well, for them, that's actually kind of become a no-brainer because they realize that they should not compete on security. So they do compete in the market, but they don't need to compete on knowing or knowledge which factory is good or bad in that sense. I also already mentioned Swiss Railways. We have a bunch of food and beverage companies using OriginTrail. We also have later for you a bottle of soon to be whiskey. So Tomasz has it over there, so you can actually see OriginTrail in action. There's a whiskey company in Ireland making probably the most amazing whiskey, and they implemented OriginTrail to track from what they call from grain to glass. So basically, so you can know exactly everything that happened during this whole time of maturation of the whiskey, which is at least 5 years. Because it's not 5 years for this one, that's actually not called whiskey, but we'll tell you that more later. And also a bunch of pharmaceutical companies. We actually helped companies deploy OriginTrail with World Federation of Hemophilia to track medicines and vaccines all the way from US to India, actually to suppress medicines ending on the black market. So that actually people are able to, get the medicine they need. But I won't go too deep into this because we can talk about this later as well. We have a bunch of time over here. So what I want to actually explain is a little bit how this works. So essentially, we can think of it as kind of a 3-layer type of system where we have, and I can essentially keep moving, where we have the blockchain layer here at the bottom, the dark one, the decentralized knowledge graph layer in the middle, and we have these DRAG applications, DRAG standing for decentralized RAG, which is a particular flavor of RAG that OriginTrail essentially introduces. And the interesting thing here is that I quickly get asked about it is which blockchain, why blockchain? So, okay, well, let's answer both. First of all, it's multiple blockchains, so that's why it's called the multi-chain decentralized knowledge graph. And the point of having multiple chains is, one is because of this principle of neutrality that OriginTrail is built on, so we basically enable people to pick a chain they would like to use, and the technology has been designed in such a way that it can connect with different blockchains. So the idea is that one decentralized knowledge graph can connect to multiple different blockchains. Also, in the second layer, this middle layer of decentralized knowledge graph, basically we have a decentralized network, which is not a blockchain. So this network is rather more akin, if you've heard of like peer-to-peer networks, so IPFS, things like that. That looks much more similar to OriginTrail, but OriginTrail has all this knowledge graph powers that we're going to see as well. And essentially, the point here being is that this network works in synergy with the blockchains below. So it listens to events on the blockchains. The nodes in this decentralized knowledge graph coordinate according to what's happening on the blockchain, because they can see the blockchain in a way as kind of an administrator without an administrator. There's no central entity that controls anything here. Rather, there's a set of, basically there's code, open source code, which is in smart contracts that lives on these blockchains, and these blockchains essentially are ensuring that nodes basically do what they're supposed to do according to the OriginTrail protocol, as well as the users. So in a way, it's kind of a system mediated entirely by code. And essentially, the decentralized knowledge graph, this purple, pink kind of mixed, nice color layer, is where all of the knowledge is hosted, while the blockchain layer hosts basically information about this knowledge, such as when it was published, who published it, the issuer, because the key of the issuer, which signed this knowledge, is actually a blockchain key or wallet, if you will, and including certain proofs for that knowledge. Finally, on top, we kind of see a layer of Web3 or DRAG applications, if you will, that actually query the state of both of the layers below. The key primitive here being knowledge assets, so the ones that I showed you briefly before, where essentially they contain this verifiable data for origin and information trail, hence the pun, OriginTrail, and essentially the key enabler for DRAG solutions. So again, blockchain here as a trust root, and DKG as knowledge there. So maybe you've seen this paper. This is if you haven't, and if you're in the world of data science or generally interested in AI and exploring papers, very much recommended, because this paper actually talks about the combination of knowledge graphs and LLMs and what each one is kind of, best suited for, and also shows kind of a roadmap of approaches on how these can be implemented together. There's many ways on how they can be implemented together. What we showed today is just like, we're going to show you the simplest way, so kind of a hello world-like way, but essentially there's a lot of different applications, and the paper is quite big, so if you're interested, I propose diving in. But essentially, you can also see on the screen a couple of pros and cons for each approach. For example, that obviously you might have already figured that out, that knowledge graphs have this structural knowledge that also kind of has this inherent accuracy. It's easily interpretable, and essentially it's usually the domain-specific knowledge. So it involves something called ontology, which is basically the one I showed you with GS1 ontology that is designed to map certain real-world events. And it's actually a branch of AI called symbolic AI. It's been around longer than large language models, but in conjunction with the large language models, it actually shines really well, because both of the technologies, some of them have con of one is kind of a pro of another, and vice versa. So in a way, you can think of them as kind of this brain-like symbiosis, where knowledge graphs are the rational side of your brain. They're like the mathematical, sometimes boring, the engineering side, and then this creative side would be the LM. You can kind of ask it to write a poem for you in the style of Shakespeare or whoever. Combining those two together actually gives us a ton of power. Very much recommend to jump into this paper. So what are these knowledge assets? Well, we basically just saw them briefly, but they're kind of a combination of 4 different things. So we have vector embeddings contained in knowledge assets, linked data, or this graph data that I've shown you. It's actually a movement for a very long time. Linked data was kind of an evolution of the semantic web introduced by Tim Berners-Lee, who envisioned, basically was the father of World Wide Web. and then envision the web of data, where data basically is able to connect to each other. So these principles embodied in knowledge graphs are part of knowledge assets, and then these proofs, they're actually the interesting thing. These proofs are the two things below, they actually sit on the blockchains. So whenever somebody wants to create a knowledge asset, essentially they pick a blockchain that they want to use, and then they essentially, using an SDK, I'll show you that, they put a bunch of knowledge inside of this knowledge asset, compute a proof, and send it to chain. When they do so, they create a transaction that actually mints this NFT. Okay, how many people here, by show of hands, know what an NFT is? Many people know. Okay, so I'll explain why the NFT. So this is not a picture NFT. It's not like a monkey or some sort of it's actually an ownership record. That's all it is. So it records who's the owner of this knowledge. So if I go on chain and Yuri created some knowledge asset, I can see that it was his wallet. That also gives Yuri some power. For example, Yuri is able to update the living data and vectors inside of this knowledge asset. While I'm not, because I don't have the key. Very simple. It's kind of like a password. So whoever has this NFT is able to do something with this knowledge asset. So you can also, for example, transfer it. And because it's a standardized NFT, that also means you can expose it to all of these NFT markets. So for example, OpenSea, we can go and connect this NFT, and whoever is willing to purchase this knowledge from you can go and do it through an existing marketplace. It doesn't have to be a marketplace customer. But also the interesting part, even though it doesn't sound exactly sexy, are these proofs. So the proofs are essentially cryptographic proofs that get recorded on chain. So that means take that graph that I showed you and compute something called, let's say, a Merkle proof, though we can support multiple different proofs. Merkle proof is like basically a hash of the graph. Well, what's really cool about this Merkle proof is you can have a very large, arbitrarily large graph. And for example, somebody can come to you and ask you to prove something. Like let's say this graph is your information, personal information, for example, passport information, or like generally your personal information, kind of a credential. You don't want necessarily to put that publicly out, right? So not everybody should have access to it. By the way, knowledge assets support private knowledge as well. However, I can, for example, come and show to Brian, for example, that a certain information inside a piece of this knowledge asset is actually contained in the entire set of knowledge without revealing the whole thing. This is what these proofs make possible. And for example, a very usual common example is you're going to a bar and they have to check that you're over 18. So normally you would show them like your ID, and then your ID, there's a little more information that they need to know. All they need to know is that you're over 18 or 21, depending on which country we're talking about. But essentially, ideally, you wouldn't show them your home address, because you never know. Like, maybe that person should not come around to your home. So the idea behind knowledge assets, actually inherited for W3C, is that you can show only this piece of information. I am over 18, maybe not even the number of the year, how old you are, but rather you can show this piece of information and compute something called an inclusion proof, showing that it corresponds with the proof on blockchain. So that means at creation, this information was in there, together with some other information that maybe you need to see. So that's actually what Swiss Database uses, for example. They are able to ask in these queries to other databases. They require certain information, but they don't need to get the entire state of all of the events that happened yesterday with French Railways. They can ask for a certain piece, and they can be sure that they're part of that set of knowledge assets over there. So what can you then do with these knowledge assets? You can do all kinds of graph queries with Sparkle, for example. In this case, you can do vector similarity search because they contain vectors. But the cool part is you actually get them together in a group. So you create something, which, and by the way, this is a new thing. We're literally talking about it for the first time today, introducing something called DKG Paranets, parallel networks. These are essentially networks of knowledge and adjacent services, such as the AI agents, LLMs, or blockchain oracles that together enable certain activity with certain knowledge. So this would be, let's say, in this case, let's say talk about enterprise sustainability. We have a Paranet that is a collection of knowledge assembled from different parties that actually you can then use certain services with. With this, obviously focusing on enabling agentic behavior and AI-based services. The cool thing about this is anybody can create them. So anybody can create knowledge assets, but anybody can start their own paranetwork on the DKG and actually even ask for incentive support, funding, basically. So you can propose on this blockchain called NeuroWeb, which is, I won't dive too deep into, but is actually an ecosystem blockchain within the OriginTrail ecosystem, launched by the OriginTrail community, which actually is designed to incentivize creation of verifiable knowledge. So if you have useful knowledge that you normally maybe wouldn't share, but now you would because you have the ability to earn the tokens essentially for this service. If you satisfy the conditions that the Paranet operator sets, then you'll be able to essentially get a certain level of reward. So if you're an operator, you can, for example, come and say, okay, I'm very interested in sustainability information. So what I'm looking for is industry reports, NGO reports, certification and standards, stakeholder reports, all kinds of things that might be interesting. They're not right now scattered all over the internet, and it's kind of hard to access them. They're also not verifiable in the sense of the proofs that I mentioned. If you were to assemble that in a Paranet and attach some services such as, for example, Google's GCP services together with this knowledge and offer it to the world, the community of NeuroWeb, if they like it, they vote in it. So it's a completely decentralized system. We don't decide this. It's actually all of the people who are participating in NeuroWeb. They get to basically vote in and say, okay, we're going to give a grant to this operator. What this means essentially, this you would set rules. You would say, okay, these are the ontologies, the formats that I want this knowledge to be. These are the topics. This is the incentive rules. Like, how would you essentially reward people who are pushing knowledge into this Paranet in tokens? And this concept is actually called knowledge mining. So the point of knowledge mining means essentially kind of like Bitcoin mining. So when you mine Bitcoin, you essentially give some computing power to the Bitcoin network. And with this computing power, you contribute to the network. The network rewards you back with Bitcoins, right? So I guess kind of by now, everybody's at least heard of this idea. Well, the idea of knowledge mining is analogous to that. So, but instead of computing power, you actually contribute knowledge to the network. So you publish more information inside of a Paranet, and then the Paranet tells you what kind of structure you should be in, what type of ontology you should follow, and how we actually value knowledge. And the value of knowledge being essentially the way, for example, Google has valued information over the course of decades. You might have heard, I suppose, the Google folks surely has, but for the others about algorithms, famous ones such as PageRank. PageRank, for example, helped with search quite a bit. From my understanding of history, was the thing that actually pushed Google ahead of everybody else in the game, because it used inherent links, the connections between websites, to essentially compute how relevant the websites or the links were to a certain search query. Well, imagine algorithms like that essentially grading the knowledge that's coming into a certain Paranet, and then the Paranet essentially based on that, let's say, taking a portion of the budget for knowledge and sending it to whoever the creator of the knowledge is. So in a way, not mining Bitcoin, but mining knowledge. You put in knowledge, and the better knowledge you put in, the more you connect it with other things. The more people use it in a way, the more usage signal, the more valuable it is, and therefore the more rewards you will get. So we'll basically show today how one can create a Paranet. Paranets are not live yet, but how it will be possible to create Paranets on the DKG using GCP and Google services, including Gemini. So I think after this one last slide, we're going to dive deep into it. This is the point of the DKG, is that it has multiple Paranets. they're all connected in one single decentralized knowledge graph, that new layer I showed you. And the idea there being is that you can do this DRAG approach on it. So take a decentralized AI solution that queries, gets question, and we don't have a question word here, but imagine there's a question here that actually does a DRAG query on one or multiple Paranets, assembles this information, does some verification if necessary, and then pushes it back into the AI model where the AI model decides what to do with it. So essentially, you ask a knowledge base assembled or rather crowdsourced by the entire world with verifiable provenance, so you know exactly who pushed in what and when. Then you have all of this on the blockchain, and including all of the structure and all of the incentives that go into that store. So what we are looking to actually create is essentially a completely crowdsourced, decentralized knowledge graph. And by the way, I missed to mention that the inventors of knowledge graph technology are Google, essentially. Google came up with this term and had a really, really good one-sentence explanation of what's a knowledge graph compared to a classic database. And they said it's things and not strings. So when you take a classic database, you're kind of thinking of tables or like some JSON objects, things like that. Essentially, these are a collection of strings that somehow you add some context to and understand them, let's say, from an application level. Well, knowledge graphs assemble this context inside of the data itself. So essentially what you're seeing, and I'll show an example, is when you create some knowledge or a knowledge asset in OriginTrail case, it's actually an object that has a specific type. It has a specific ontology. Therefore, for example, if you go to do a search in Google today for, let's say, Albert Einstein, what Google will do is one of the things it will act its knowledge graph. And the knowledge graph of Google will understand. It will say, okay, I actually understand you're looking for a person. You're not looking for a set of characters that happen to look like Albert Einstein. I understand you're looking for a person. That's been happening for a long time. So, question?
Yeah, because this is very technical and it should be. If you could just help the audience understand with a couple of use cases, retail use cases, or at least hint to the new examples that are being built, which are really getting closer to just about any user, not just technical users, not just enterprises, because this is already live pretty much. And
yeah,
I think it's the use cases and the type of organizations that are making a very good example.
You want to give me that ball? Yeah, so I can show it perhaps. So this is one of the use cases that Giga mentioned. But like quite often interacting with something like food, for example, let's say in Slovenia, we have a couple of food producers that are using OriginTrail to enable this DRAG AI interaction with the user. So consumer can scan a code like this. This is something called GS1 digital link, but you can consider it kind of a powerful barcode that actually connects to the linkage and it opens up an interface like that where you can chat, and that actually goes into the linkage and queries the information about the production of exactly this one or exactly that piece of chicken or beef. And that's already, actually you can find a lot about that on the OriginTrail website. But essentially though, that's live today. So if you go to a store, for example, in Slovenia, you can scan organic beef and you can ask it like literally with using Google Trip, by the way. With voice, you can ask like, okay, is this meat organic? And we'll go and find inside of the knowledge assets, and we'll find this particular certificate, because it understands you're looking for an organic certificate because that's labeled in the graph, and we'll find out how this is a certificate issued by country of Slovenia, and so on. Or for this one, well, I'll let you actually scan it later yourself. And perhaps you can also try it, though I think it's like 50% something. And I don't know what the Google policy on alcohol, so I'll leave it at that for now.
Next to the glass, it's good. Yeah.
Next to the glass, it was good. Yeah. Awesome. So I think we are.
Just maybe one more point. I think that
You can stand up and say it. Yeah.
Just on the point of the Paranets, I think one interesting thing is when you think about them, they can be arbitrarily big or small. So you're building out the use case. You can consider a Paranet a tool of how you connect the knowledge assets that are relevant for whatever it is that you're creating. So you're the one setting the ontologies. You say, okay, you have to use this data structure so my solution can understand it or my service can understand it.
and this is how I want you to design it. Or you can say, you know what, I want to go after cancer, so I want to create the whole body of knowledge around this. And I feel that we should garner as a humanity around this particular field, and we should really put like a huge amount of knowledge within this Paranet. So they can come in smaller or they can come in larger sizes. We have here folks that are using and creating their Paranets for their kind of desires to create the differentiation on the marketplace, and they're going with TV ads showcasing how this actually works and how people can interact with Paranets. And they, within that Paranet, they have that same thing. So they have the ontology, they have all the things that kind of defined, and they may allow others to kind of come in and be contributing to that particular Paranet. But some might be saying, you know what, we want to create something. A good example is an international sports organization. What they're saying is, look, we want to create something which is going to consist of knowledge assets that we feel should be there to allow people to interact with them, with the service that we're creating. So for them, it's maybe less on the side of, let's say, contributing from everybody around, but they want to kind of keep it, their Paranets to be more and more defined. And in some other cases, it's going to be totally crowdsourced. It's going to be, I don't know, Paranet of anonymized healthcare data, and you would just want to kind of, have a lot of folks kind of getting in and contributing to it. So just that element, when we're looking or seeing how Paranets is going to literally like launch a Paranet on Google services, you can think of it along the lines that this can really be either a use case example, or it could be like a portion of society that you're trying to attack with something like that. Yeah, there's those two points.
Thank you. Thank you.
I have a question.
Yeah, go ahead.
When you talk about Paranets, is that specific to any chain as such, or is chain agnostic?
Very good question. So one Paranet lives on one blockchain. So that's a parameter that you have to define when you essentially define Paranet. So let's say if you were to start a Paranet, you would describe it first, and you would say, okay, it's this chain that I want to use for this Paranet, and it has to be one of the chains that are supported by the DQG, but also can be a good signal on actually adding support to an additional chain. And then you would create a community proposal. Essentially, you would very similar to, for example, Polkadot governance, if you know how that works, where you can propose to the community and say, okay, this is what I want to build. That's how many tokens I need, and everybody votes that in if they vote it in, and the funds will be distributed to say an address that you can then leverage to apply for knowledge mining. But it's on one chain.
Add to that question.
Yes.
Does the chain that the Paranet uses and the knowledge asset used have to be the same, or can they be different?
Very good questions. They don't have to be the same. So if you want to put certain knowledge assets in a specific Paranet, then it has to be on that chain. But Paranets are inherently connected on that middle layer. This layer, the purple layer. So essentially, it's kind of like a semantic web where all of them point to each other. And by the way, the identifiers for knowledge assets, I missed to say, are actually kind of an evolution of this semantic web principle. They're actually combinations of blockchain URIs, which are these NFT URIs, and the graph URI. So they're actually self-resolving. You don't need like a DNS or something in between. You can resolve them yourself. But so therefore, because they're self-resolvable, like you can take two Paranets and you can connect data between them. And but like one Paranet has NFTs and proofs of that one chain. That's correct.
Cool. And also maybe this is the TRAC applications, right? You can then also query multiple Paranets. You can query all of them. So it depends on what you need, right? You can really focus on that use case.
So the idea is not to make some sort of silos again here, rather to use
Knowledge graph of knowledge graphs, basically.
in a way, yes. So actually, this is the last slide. No more slides. So I think that's pretty cool, right? Okay. So where do we go now? We go now to actually showing you one of the first things, like how you could use OriginTrail technology with GCP. So what I'm gonna do is, and it's actually, so I can do it here. So I have this code for later. Actually, yeah, let's do it like this. So what I'm going to do here, I'm going to hide this. Okay. Come back there again. Okay, so what I'm going to do is actually I'm going to connect to a GCP VM instance that we basically already provisioned. And I'm going to run an OriginTrail DKG node. So one node that will basically be part of. I'm probably going to need like 5-10 minutes to set up it. Okay. Basically, I'm going to show you how to do it. And just imagine that before this, you basically ran, let's say, an Ubuntu connected to the internet.
We can do another show of hands. How many of you are running nodes?
Yeah, how many people are running nodes in the community? Okay, there's 2 hands over there. Nice. Okay,
All right.
awesome. Awesome. Thank you for the support. By the way, whoever is looking into whoever is looking into doing this, you can run onto the docs.origintrail.com. So like ton of explanations here. Of course, I have to go a little bit faster to it. But basically, if you go to this running the DKG node page, you will see all of that, including explanation such as what is a gateway node, which is what we'll set up today, and what is a full node. I believe those guys are running full nodes because actually, that's a thing to mention. A full node is a node that hosts the DKG and the Paranets, and actually is financed by the fees, the publishing fees that are being used to use the network. So there is no central entity that would actually in any way. Oh, nice, awesome, thank you. So there's no central entity like that. It's all governed by smart contracts. So when you're using this infrastructure, obviously it's not free. So people, just as the community members over there running nodes, also have to pay costs of those servers, right? So to cover that cost and make some money on top, actually, the payment comes from the usage of the network. So the tokens that are being used, called TRAC tokens, are actually locked when you publish some old asset. And then nodes actually get to claim them when they prove that they held them for a certain amount of time they did. So what I'm going to show you today is actually not a full hosting node, though the difference is very minimal, and you can read all about it. I'm going to show gateway node. So gateway node is a node that basically lets you ask, consider it as kind of a modem. So like once you have an access to a gateway node, you can query the AKG, you can create market assets and do all kinds of things like that. And like I said, if you go through the instructions, it will give you all kinds of installation prerequisites, hardware requirements, what are the blockchains that are supported, things like that. So I'm going to kind of run a little bit through that and show you that basically how the installation looks like. So actually what I need is this. That's what I was looking for. So I'm going to just SSH into this instance. So that is, I'm going to be root because that's how I roll. It's 27, 23, 91. And by the way, what we're going to do today is we're going to, okay, I'm in. So we're going to set up a testnet node. So the DKG has actually 2 public networks, the mainnet, which is the ones that are used in production, essentially the testnet, which is kind of a more development environment, or other staging environments. Is a copy of the mainnet in terms of the code running there. There's also certain development networks, but they're used just for development purposes. So now that I'm in this server, obviously, what I'm actually going to do is I'm going to download this installer. So what I just copied, I'm just going to, like, basically what happened here is I download the installer. It should be here. Yes. So I'm just going to run it, and the installer, setting this up on GCP, is going to take me through the steps. So what it's doing basically is installing some prerequisites, and now it's going to kind of start asking me things. And I will use this time to explain actually what's under the hood in the node. So the node is one network unit that communicates with other nodes. It communicates to this peer-to-peer system, and that is actually going to be set up. So for that, we need a set of keys so the nodes can identify themselves. The node also has to host a portion of the node graph. For that, it needs a graph database. So now it's asking us which one we want to use. Currently supports BlazeGraph and Fuzeki, but actually it can support other ones as well. So we're going to just pick BlazeGraph for now. It's going to download it. By the way, all open source technology. Now it has to take also needs a relational database for internals. So we're going to take SQL here. And while that happens, essentially it basically is installing everything under the hood. So a node is kind of the decentralized knowledge graph, you can consider it's kind of like a kind of a syndication of databases of different nodes that are connected, and they each host a portion of the graph. Contrary to a blockchain, where all blockchain nodes process all events and generally host all of the blocks, which is also one of the kind of the unsustainable elements of blockchains. It's just like hundreds of computers around the world doing the same thing, hosting the same thing. You know, it's obviously the reason for this is this verifiability and security. Bitcoin, for example, being the oldest blockchain never being hacked, right? SQL password, should I change? Yes, I want to change it. Let's set it to one. Something like this. Okay, SQL is set up. So it's now asking me what kind of node I'm going to run. I'm going to run a tested node, and it's going to ask me which blockchain I want to connect it to. Actually, OriginTrail parachain is still not updated. This is now called Euroweb. We're going to pick Gnosis blockchain, which this is an Ethereum basically sidechain that OriginTrail is deployed on. And what it's asking me now, if I pick Gnosis to deploy this node of the Paranets on, is an address of some wallet. So this is the wallet that the node will use to send transaction for blockchain. So I basically prepared the wallet previously, and it has an address here. Let me just see. So this one, so I'm just going to paste it here. Also, obviously, the node needs a private key. Otherwise, it couldn't send transactions or sign transactions. And awesome. So, anyways, I set up an operational log. I can set multiple, so node can actually use multiple ones, so they can dispatch multiple transactions to blockchain at the same time. But we don't need this for this demo. And it's asking me about this EVM management wallet, which is actually an admin key. So what I just set up is basically some keys to manage the node on chain, manage its identity on chain. And the operational key allows the node to operate, send transactions. The management key allows me as the admin to manage the node. So I can change operational keys. I can change different things. And obviously, the operational key is never stored. The operational key is stored on the node. The management key is never stored on the node because of it doesn't need it. So therefore, why would it be there? Now, I'm just going to enter two more values. I'll explain later over drinks why this is. But let's say my node token, and let's say my node. And I can set actually an operator fee. So me as a node operator, I'm able to say, okay, I want to basically keep 15%, for example, of all of the fees that the node accumulates before sharing it with others who participate in my node. Finally, I need an RPC endpoint, which is somewhere here. Yes, here it is. And I think I don't need anything else. I think it's now installing finally. Well, I basically need to connect to the node, but essentially this is, once you get all of the stuff ready, like I said on the docs, explained pretty well, the installation kind of runs around 5 to 10 minutes. If I were speaking faster, it would be faster. I apologize for that. I'm trying to explain what's happening. So, zooming a little bit out, these are the details, some of the details of the node. Basically, now this node is installing all its components, and then once we start it, it's going to create its identity on the blockchain. In this case, Gnosis testnet, and it's going to start connecting with other nodes. So we'll see that in the log. Once that is done, I'll actually connect to the node and create one very simple hello world knowledge asset and run the query. So you can see that it's not incredibly hard. And then we'll have Marco join us. I got something red popping up. I hope it's all okay. But yeah, we have a node running. So this is the OriginTrail node, version 6.1, the latest version. Actually came out today on mainnet. And if you look into the logs, you're going to be able to see all kinds of interesting things. But what we're looking here is, yeah, there's 50,000 TRAC on this key. So if you drink past the tokens, you can grab them.
Please wait until the demo is over. And
So yeah, basically the node, I'm just looking to see if it's successfully started. So it's catching all of the necessary information. in the initializing blockchain. Yeah, so here it says node is up and running. So basically that's the log I'm looking for. It initiated all the network protocols. These are the key three protocols. So get is obviously to get knowledge assets, update is to update knowledge assets, store is to store knowledge assets, right? So basically the node is now, it shows here, it's connecting to other nodes in the network. These are the identities of the nodes. And it's kind of dialing them, establishing these connections in a decentralized way. Now, logs are not so interesting, so I'm gonna just stop this. And what I'm gonna do now is basically just gonna let myself actually access the node. So what I need to do is I need to just create a token for the node. And this is not here. I was in the right place. So I need to go into the OT node. And what I need to do is I need to generate key. So testing track. So it's testing track. So yeah, I need to basically go into the let's say I need to add. So you can also see like SQL password here, of course. But what I need to do is I need to add the JVT secret, which I prepared here. So essentially what I'm doing now is I'm just creating a token for myself. This is some random string as a secret. Normally it's a secret, not like today. Normally you wouldn't share it with anyone. But having this, I would basically, what I would do is, I'm not sure if I copied this command here. I think I didn't, so I have to type it now. So basically what I need to do is I need to run tools, token generation, and say token name is, let's say access 1, let's say that's my token, and my user is runner, and expires in, I think it's like this. What was the date? Okay, something like this, seconds. So this is a millisecond, so I guess, let's see. Okay, so I basically got a JVT token. For those of you who don't know what this just lets me connect to this node. So what I'm going to do now is actually I'm going to zoom out a little bit. And I'm going to go into, so a project here. And I promise I'm going to speed up a little bit. So I'm not going to code anything. I'm just going to show you. Okay, I can't even paste the JVT here, but I have an M file. So just a second. There it is, JVT token. Okay. So what I'm going to show you is a very simple example of how, like a hello world, creating a knowledge asset. So right now I have this token, the node is set up, and using the DPG client or the SDK in this case, I'm going to just basically connect to it and create a knowledge assets. I'm trying to zoom in so you guys can see a bit more. Just to take you through the code, it's very simple, nothing special here. So this is just us taking in the environment file that contains this key that I created and some other basically parameters such as the IP address that you've seen on the node, the port and stuff like that. And what I do is also basically after installing the SDK, in this case a JavaScript SDK, dqg.js, I basically instantiate the SDK this way. So I provide it a certain environment, testnet, the blockchain, the keys, the token. So just so that my SDK can actually do something with the node. And then basically, once I instantiate the SDK, I can connect to the node. So what I'm going to try just to make sure that the connection is working, that I didn't mess something up. I'm going to comment these two out and do it. Will we go up? It will go up. Okay. So what I'm going to try is demo.js and just checking. Okay, I messed somewhere up. What did I do? I'm able to get node info. Yes, I forgot something. I need to go back to the node. So I need to go into the configuration. See, just here in the right place. Yes. So I need to add one more thing here, which is, I remember how it is. I think I wrote it up. Did I? No, I didn't. Okay. Okay, so bear with me. I just need another moment. So it's called IP-based. So I'm turning off IP-based authentication, so you can basically whitelist your IP address and access it like that. But we're going to do it a little nicer. So token-based authentication enabled, and that we're going to set to true. Actually, this should be okay like this. I think I'm going to need it's not a string, but I do need a comma. So okay, and then I need to do restart and logs just to see if it's all running. So I just restarted the node, so it loads this new configuration up. So it actually lets me connect with the tokens. And there it is. So the node is going up. I can go back to the previous terminal. It's taking a while. I think maybe my connection is slower than it should be. Gives me enough time to take a sip. I'm good, thank you. Yeah, let's try again. So here. So all I'm trying to now is basically just connect to a node. I guess I'm still not able to connect because the node hasn't fully initialized. Okay, now it should be. Okay, cool. So I got this tiny log which says version 6.1. So that basically said that I managed to execute this function. So I'll show you. I basically tried to call the dkg.node.inf, just saying if I can actually touch the node. I can, that means this whole mumbo jumbo with token authentication was done. So now I can actually create a knowledge asset. So to create a knowledge asset, I'm just going to show you how that's done. Basically, all you need to do is call dkg.asset.create. You provided some content and you provide something here. I'll explain that in a moment. But what is the content? Well, basically, I can put in any JSON LD object here. Who here knows what JSON LD is about? Few people, okay. Who here knows what JSON is about? Okay, that's few more people. So the difference between JSON and JSON LD is kind of this knowledge graph JSON, where you can define the type. You can say, okay, this is the ontology, this is the type of the object. Actually, why don't I show you? So for example, we can go to JSON LD Playground. It's a usual dev website. So for example, if you want to call a person JSON LD, the person looks kind of like this. So the difference from normal JSON is it has this context parameter and type parameter, which basically says that actually all of these properties here are not just plain string properties, they're actually strongly typed properties. So actually, the way this looks like expanded, as they call it in JSON LD, is that every property, such as job title, actually looks like this: schema.org, schema.org/name. And schema.org, also, by the way, brought to you by Google and other search engines, is the one that actually created this whole system of this linked data. Like I said, previously used in search engine, currently used in search engines heavily. If you've done anything with SEO, probably you ran into JSON LD. And actually, why don't I take this as an example? So I can just jump in here and I can say, okay, this is going to be the content of my knowledge asset. Maybe it doesn't have to be Jane Doe, maybe it can be me. I'm professor, and my website is here. So basically, you can also use JSON, but if you really want to use the knowledge graph, you would use JSON LD, or you can use one of these other serializations. So for example, this will be an M-quad serialization. This is a canonized version. There's a bunch of these different ways to represent basically knowledge graphs. So, and actually, when you create the DKG, you can get all these formats out. So, okay, now that I created this, I can just rerun the script again, and hopefully that's going to create a knowledge asset. I messed somewhere up. Okay, yeah, I have some extra. No, that's good. Okay. Yeah. I should kill this. That's the problem. Copied everything. So third time's the charm. Okay, we connected to the node, and now it's creating a knowledge asset. So what's happening under the hood is actually and it takes a little bit because actually a blockchain transaction needs to happen. So right now there's a transaction being mined. If you're a user of blockchain, you know that depends on the blockchain, but it can be like 5 seconds, can be 15 seconds, can be 15 minutes in the case of Bitcoin. Here Gnosis, it's 15 seconds if I'm not mistaken. So actually what the node does, what actually my script here, as DK did, is it took this content, it signed it with my wallet, and it actually sent out this transaction to the blockchain, and it looks like I got some error, of course, and then we can basically also close it here, not to take up all the time because we have another set of the demo, but you can trust me that it will work. This is what actually we're gonna get. We're gonna get this thing called U. I can maybe try it again. I don't know why it's working. Maybe I didn't set up the node properly or something, because it looks like something didn't get through, and it could be that it's it could be that I didn't set something up well. So, but in any case, I'm trying it again. But the point is, essentially, after this transaction happens, all of the nodes in the network see that actually there is a certain set of tokens there that can be earned, and there's all of the necessary materials on chain, the NFT, the proofs, so that they can actually prove that they posted this information. So the nodes then exchanges knowledge assets among each other, and it's hosted, it's replicated across of the DKG. Okay, this time it worked. So I don't know what I did, but like somehow it managed to go through. And like I said, this is the URL of this knowledge asset. So if I were to go, let's say, to DKG Explorer, the testnet Explorer, so this would be DKG testnet, testnet, and if I paste this URL here, it should fetch it. So yeah, here it is. That's a knowledge asset. That's the Professor Brana Rakic with JDO website, obviously something random, but you can also check out this NFT here. So if we click on this link, we're going to see the NFT on Gnosis blockchain that was just now minted, that basically represents this knowledge asset. This is the owner, that's me, the key that I just used, the public key that I just used. That's the one that has the 50,000 whatever trace or something, like a lot. And you can see, like we've actually, yeah, we didn't have a broken transaction, so something probably that I haven't done right. But in any case, like I said, all of this information sits on chain, the NFT and the proofs, and then we have the knowledge asset sitting in the DKG. If I were to use a URL of another knowledge asset within the content of my knowledge asset, I would now be able to traverse through that. So I will be able to click and go into other knowledge assets here, and that's how we achieve this connectivity. But in order to not consume all the time, which pretty much I always do, I'm gonna basically stop here and let Marco join us. Marco, are you around? Can you unmute yourself?
Yeah, I'm around. Hello, everyone.
Hello. Hello, we can hear you. Awesome. I'm gonna stop sharing my screen then. Marco is gonna show you now how this comes into play with Gemini. If I can figure out how I can stop sharing my screen. Here it is.
What I will show you here is, well, a simple demo, let's say, about how you can do knowledge mining and also how you can do the decentralized RAG on a Google Paranet, let's call it like that. And yeah, just to introduce myself, I'm Marko Brkic, and I work at Jace Labs, who are the core developers of OriginTrail. And yeah, I mainly work on AI. I'm an AI engineer, and yeah, mainly work on this ChatDKG initiative and creating AI solutions such as this one. So yeah, what I will not show you is how to install Python packages and also how to authenticate with Google Vertex AI and Google Cloud. So what I will show you is here we will install first dkg.py, which is similar to what Branimir showed. It is our Python SDK for interacting with the DKG. It makes it a lot easier. And yeah, just to give a small, let's say, peek into what we will be doing, we will instruct Gemini, the LLM, to create a knowledge asset on the DKG. And this is what we kind of recommend to some of the knowledge miners as an, let's say, easy way to create knowledge and create a bunch of knowledge assets. And later we will also instruct this LLM to construct Sparkle queries, which are kind of like SQL queries, but they're for the graph. That's why the language is called Sparkle and not SQL. And using this retrieved data, we will create the centralized retrieval to power the centralized RAG that Branimir introducced. So hopefully it's, oh, my runtime disconnected just when the demo started. So let me see if I can fix this very quickly. Okay, it seems that it's working. So yeah, I will do some quick live coding about DKG-Pi because Branimir also already showed the DKG.js. So what I will do is I will import the DKG. And like we briefly discussed, we have two, let's say, ways of communicating with the DKG. It's via the blockchain and with the transactions which you need to create knowledge assets, and also the node HTTP provider, which is mainly connected to the graph and querying the graph. So what I will not be doing is showing you the private keys and stuff. So I am copying this. Let me just see if my N file is here. It is. Great. So what I will read from the N file is the JWT token for authenticating, and also which node and which private key I will be using. So I will also instantiate the providers. So for the HTTP provider, I need the host name and I need the token. And for the blockchain provider, I need to tell it, just like Branimir did in JavaScript, I need to tell it the environment. We will use mainnet here. Also the code of the blockchain, and pass the private key as well. And also, just for the sake of this demo, we will pass a higher gas price, which is, let's say, how much we are paying for the transactions, just so they don't, just so they are as quick as possible, basically. And yeah, I will create the DKG from the blockchain and node providers. And just as Branimir did, we will print the information of the node just to check if everything is fine. I'm hoping that the disconnection of the runtime didn't screw something up. And here I have a typo. But yeah, this shows how simple it is basically to use these SDKs to set up your connection to the DKG. And yeah, we have it working, which is good. And now what we want to do is we want to instruct Gemini to create a knowledge asset. So like Branimir showed, knowledge assets are created from these JSON LD schemas. So what we want to do here is create a prompt that will help Gemini understand what we want it to do. So we wanted to construct a JSON object following an artwork JSON LD schema. So what I didn't mention is that we will be using here an artwork example. So currently in OriginTrail, we are actually incentivizing people to create artworks. And yeah, that's basically knowledge mining. And here you can use the LLM to help you with that. Either like some of the use cases would be, you don't have to be very technical. You could just pass a human a query in English and it will create a JSON object for you. Or you maybe want to scrape the internet and create a bunch of knowledge assets. It's very useful for that as well. So here we will the user will provide the image URL, artwork name, whatever it needs. And for the publisher name, we will use this Google Amsterdam demo. And also the LLM will add 5 keywords. And yeah, we basically gave it some instructions and we gave it an example of one of the schemas we want. So here I'll just quickly show maybe a bit of coding. In case you're tough with time, feel free to let me know. But maybe some interaction with Gemini would be nice to show. So here we can write, basically what I set up here down below is a chat history with this prompt message from the user and basically an understood message from the LLM. And here we want to create a function that will be able to produce, let's say, continue this conversation from these two messages and, you know, allow the user to actually provide what he wants. So yeah, here I will need to pass a chat, which is a chat session, and a prompt, which is a string. And the response will be, we'll be able to send a message in the chat, and we have to pass the content, which is the prompt, and we will also pass some generation configuration here. So let me just type it out and I'll explain what it is. So just to reduce hallucinations, we want to pass temperature 0, and that means that the LLM will not be creative at all. Basically, it means 0%, let's say, creativity from the LLM, and it will always output the same results. So that passed well, which is good, which means that everything is working correctly. And here we will instantiate the Gemini Pro model, and also here we will also use the temperature 0. And we want to start this chat, so we will do chat equals Gemini model dot start chat, and we will pass the history that we just created. Great, and we will also get the generated JSON from the question, and I will shortly read the question that we want to do. So what we want to instruct the LLM is to create an artwork with this name, decentralized hexagon. This is some random name that we thought of. It is created by OriginTrail. We gave it a description, and we also gave it the image URL, which I can open, I guess, to show you. So this is some image that actually Branimir created, which is cool, kind of reminds of the DKG. So yeah, what we'll do is run this and see what the LLM has generated. We will probably be happy with this. Let me just see if I ran everything. I didn't return here. Thankfully, this also happened when I rehearsed, so I knew exactly what it was. Great. And yeah, what we expect here is the JSON in the JSON-LD format, exactly like Branimir showed on the website. Here, this is just a function to clean the JSON from this, what LLM likes to add some sort of, this is very understandable for the LLM, but we don't need this in the DKG. And we will load this string into a JSON object, and we want to create a public knowledge asset. That's why we added the public property here. And we basically, we want to mine this knowledge. So we want to create a knowledge asset which will live for 2 epochs. And do basically the very similar demo which Branimir showed, which is getting the knowledge assets. And this will run now on the mainnet, and hopefully it will be as quick as possible. So while the create is running, maybe I can give a short introduction to what we will do next. So the next thing we want to do is we want to instruct Gemini to construct a query, which is a Sparkle query, which is a language for querying graphs and knowledge graphs. And we want to use that query to query the DKG. So for example, if the user wants all the assets created by, what did we put here? Google Amsterdam demo or something like that. Then once the user enters that question, we want the LLM to create the Sparkle query, which will form a query which will retrieve all the assets which are published by Google Amsterdam demo and actually retrieve that data from the DKG, which we will later pass to the LLM. And it will be much more efficient for the LLM to do its generation once we pass it, let's say, a smaller data set. Instead of looking over all of the artworks and then trying to figure out which artworks are published by Google Amsterdam demo. So hopefully this create will be done soon. While that's going on, we can take a look at this prompt. So we told the LLM that we are working on a project involving artworks, that we use a JSON-LD schema. We gave an example of the JSON-LD schema, and we gave an example of the Sparkle query. So as you can see here, Sparkle is pretty similar to SQL. It has a select clause, it has a where clause, and also it has this graph clause, which is a bit new. And we use that to retrieve the UAL, which is the identifier of the knowledge asset. This is still running. And this identifier is used to retrieve the content of the asset from the network, and that's what we want to show later. Okay, so I'll just go on, and hopefully the asset is created in the meantime. So once we create this prompt for the LLM, we will again set up the Gemini Pro model just like we did before for creating the JSON schema. And we will start the history, the chat, and we will ask the question that I mentioned. We want to get all the artworks published by Google Demo Amsterdam. So here it says an error, but I have a suspicion that this actually worked. So let me just check, and I'll explain what I'm checking now. Okay, great. So for some reason, our Python SDK is not very I mean, it's production ready, but it does have some errors. So here, what we have is the OriginTrail World Art Registry. So there are already 78 pages of art. So we are creating art here, and this is our decentralized hexagon, which was just created. We can see it here on the DKG Explorer. And yeah, this is the URL which we would use to do a get operation, just like Branimir did. But because this crashed, we will skip that part, and hopefully show you this on DKG Explorer once it loads. So yeah, I'll just run these cells about SparkQL, which I showed to you before we go on. So we successfully managed to mine this art, and yeah, here it is. We created it 3 minutes ago, just so I'm not like lying to you that we actually created this. And yeah, here is the hexagon, and here is the image. And here we can inspect that the LLM did the right thing. So it's generated some keywords, blockchain, decentralized hexagon, etc. And also the publisher is Google Demo Amsterdam. Great. So we showed basically how you can mine knowledge. This is very cool. You could also mine a ton of artwork like this using the LLM, which is very good. And what we did here is we ran the generation of the SparkQL query. So we wanted it to provide me with all the artworks published by Google Amsterdam Demo. So let's look at this SparkQL query. I think it's written nicely here. So we select artwork, name, UAL, where it is type visual artwork, and the publisher is Google Demo Amsterdam. So this seems pretty good. It should be able to run on the DKG. And here, what we will take a look at later, but we spent 700 tokens here that will come into play. And here we will use DKG Pi to query the DKG and basically do the retrieval from the graph. And we get here, I think there are 3 assets which were created by Google Amsterdam Demo. And this is the final step where we do the generation. The LLM does the generation, and it's boosted by this retrieval that we did. So we format these results nicely, and we tell the LLM in a prompt again what we did. We retrieved the information from the DKG, and here just for some, let's say, interesting part of the demo, we tell it that it's a guide guiding us through a virtual gallery, etc. Maybe just for the sake of time, I will run it, and we will see what happens. And the cool thing is we also have a UI for this. So it's probably prettier to show it there. So we wanted to provide me with all artworks from Google Demo Amsterdam. And yeah, currently it's thinking. It needs probably about, let's say, 15 seconds to get the results. And here it is. So we have 3 of them. We see here that one of the source knowledge assets is this decentralized hexagon. And here's a story that we told the LLM basically to invent. So let's see, for the decentralized hexagon is a visual in representation of decentralized web, a new paradigm for the internet, which is based on the blockchain technology. I won't read everything, don't worry. And yeah, here we see the 3 images that we created. These were done previously, and this one we did now. So yeah, this is pretty much it. We did the knowledge mining, we did the retrieval from the graph, and now we did generation helped by this decentralized retrieval. The last thing I want to show is let's compare if we just did basic RAG, which would mean that we passed all the artworks, which this query does, to the LLM, versus what we did now with this knowledge graph retrieval. So I think Gemini can maybe even take 1 million tokens in one prompt. Maybe someone from Google can correct me. So it's actually possible to use Gemini for this. But obviously, it's going to take probably more time, more money, more tokens. And yeah, that's what we want to compare. So here I even had total token count. Okay, so for the LLM query, where it generated a SparkQL query, it's wasted 700 tokens. For the query, okay, I think this is just duplicated. And for the last part, where it formatted the results into a human-readable text, it used 750 tokens. So I think it's in total 1,500 tokens. And I think this will run for quite a while because we literally gave it 78 pages of art to conclude. But let's just remember that it's 1,500. And yeah, maybe the demo is too dynamic and I'm too much jumping from one thing to another. So maybe let's just wait for this, and I'll explain to you here. Maybe I can show you the DKG Explorer of this decentralized hexagon. So yeah, here we have what we created. And yeah, okay, I'll just jump to another thing while this is going on. So I wanted to show you another question here on this UI. I wanted to show you this, provide me with 5 artworks of art from type AI generated image. So what we want to do here at OriginTrail is with this art example, we want to basically reward people who create original art or art that is derived from their art, basically AI derived art. So here, for example, we have this AI cowboy art piece. And if we go into it, this is cowboy. If we go into it, we will be able to see on the graph that this knowledge asset is actually connected to the original knowledge asset, which is original art. And yeah, the goal is basically to make it fair, so people cannot steal art and just create AI-generated derivatives, but actually reward people who created the original art.
It's still going, right? Do you remember how was it last time you ran it? How many tokens?
Oh, yeah, I remember, of course. It was like 30,000. So basically we did a 20x decrease. And yeah, this is what I wanted to show, the last thing. So the asset is based on the original asset, and that way we can reward the original creator. Actually, this ran, and here it is, 30,000.
So maybe just kind of a small summary. What you saw is basically kind of the way we think is a good way to use a generation of art with AI. So if you want to generate art from existing art, at least the minimum you should is kind of attribute the original creator of the art. But in this way, you can also do much more. You can basically directly point to it. And if you do that in the DKG or in the art Paranet that is about to be, is that actually helps the original creator also earn some of those tokens through knowledge mining. So that means if a lot of people take your art piece or your knowledge asset in a general sense and create something out of it with connection to it, they do this kind of similar PageRank thing where they essentially give signal to your knowledge asset, therefore making it more valuable, therefore enabling it to essentially enabling you as the creator to earn more incentives. Contrary to we train everything, LLMs with everything, and then, the artists are kind of more to be seen. And one of these artists, and that's the last thing before we ask Professor Bob Metcalfe to join us, is actually one of the artists from the OriginTrail community who is doing something really interesting, and he sent us this so we can actually show it, the demo here. It is it's incredible. It's much more than just visual art. It's actually a whole storytelling universe, or called omniverse in this case. And because it's related to OriginTrail and then dedicated to OriginTrail, it's called TRACverse. So what I'm going to show you in this TRACverse, which I totally recommend you jump to tracverse.com if you're interested in all these new experiments with metaverses. And actually, we're going to show how you can load a knowledge asset, a whole story from a knowledge asset. So what we've seen previously was, ways to interact with knowledge through Gemini, through SDKs, through the Explorer, the chat interfaces. But those are just some ways. Like essentially, what we're looking at is that one big permissionless, decentralized knowledge graph that anybody can access, anybody can write to. And he created a story. So this is the decentralized identifier of that knowledge asset, that story. And if I click query, it actually is going to load that from DKG, and it's going to kind of give me basically a story that looks like a kind of an engaging storytelling comic book-like gaming experience. I don't know how better to explain it. It's incredible. You should go see it. So essentially, you can essentially view it on the DKG. You can retrieve this interactive lore. And you can engage with this story. So once you jump into this, you can actually go through this whole world of TRACverse. And TRACverse is actually very interesting metaverse. It's about creating kind of a history of all of the digital universes, metaverses, virtual realities, all of these particular things. And I'm particularly excited about this, not because the guy who's doing it is cool, but because it reminds me a lot of what we find very much inspiration in is Isaac Asimov's Foundation. So if you read that book, this is kind of like Foundation, recording all of the history of human knowledge metaverses and digital art, essentially, in kind of a special type of storytelling framework. So I obviously am not going to read through this, but by the way, also AI generated for images and stories. So you can go and explore directly on Trackverse. Much in the same way, OriginTrail is about essentially creating the biggest crowdsourced knowledge base, trusted knowledge base in the world about all human knowledge. So I'll stop this presentation here to conclude and to invite Professor Bob Metcalfe for a panel by inviting you also to contribute either by creating your own knowledge assets, joining the community, building with OriginTrail, building OriginTrail. It's all open source. So if this today was in any way exciting, we'd be happy to have you join us. We're a very open community. There's a lot of community members around who actually flew in, like super surprised and super happy they did. And yeah, just let's build all this big, huge knowledge base together. Thank you, everybody. All right, Professor, thanks again for joining us, and hopefully you also learned something, like you mentioned in the beginning. Yeah, after these initial connectivity problems, we're super happy to have you and to chat. We won't make it a huge chat because I think the audience here is very eager to also get into the beers later. But we wanted to just jump into a few topics together. Together with me is Boyan from Google, who also will be chatting. The three of us will be exchanging a few ideas. And I guess Boyan, I have a question for you that you might find interesting. You can start with your question.
Yeah, so Professor, it's really a privilege to have you here joining our meetup today. And here at Google, we have also opportunity to hear a lot of interesting stories from technology pioneers, such as, for example, Windsurf. And I personally enjoy listening stories about internet development and including, for example, interplanetary internet. So this kind of things. So maybe it would be nice if you can share with us a few anecdotes from those early days of the internet, and maybe if you can make a parallel with emerging technologies nowadays, like generative AI, and how do you see basically technology develops from its early days with its ups and downs, and where do you see this particular technology now in that cycle?
You didn't warn me that there would be beer following my remarks. And I can't possibly explain each and every line of that node creation demo that we just saw. I have to do that more slowly offline, I think. So let me explain why I'm hanging around OriginTrail and Trace Labs is because well, it goes back to 1968 when I wrote my undergraduate thesis at MIT in electrical engineering. My undergraduate thesis in electrical engineering in 1968 was a neuron model and some of its information processing capabilities. And my thesis advisor was Marvin Minsky, one of the founders of AI. So the point being, I've been watching AI for a very long time. And one of its features is that it tends to come and go. It has come and gone a few times. And my analysis is that it goes when it runs out of data. That is, like expert systems was one of the manifestations of AI, and it ran out of data and crashed. And so I'm watching really carefully at this blossoming of AI, which appears to not. It appears to have escaped the data problem. That is, we now have the internet. We didn't have the internet before. And so now today's version of AI, which is now blossoming, appears that it's not going to crash from a lack of data because there appears to be data around. Now, the thing is that, and this is why I'm hanging out here, learning as everything I can, is that we need to complete the data portion of our our exploitation of AI. The AI is right now too susceptible to what do you call them again? Delusions, I guess they're called.
Hallucinations, yes.
Hallucinations.
Pretty
yes.
much delusions.
Delusions. And what's going on here is in this community is where we're trying to finish the job, that is give access, make our AI models now being able to operate with trusted information rather than simply statistical correlations. And right, it's happening right in front of us now. We're right in the middle of it. And the two key processes which have worked in the past and are now working here are emerging standards and killer apps. So there are, we need to figure out what kind of standards we need to advance this technology, and then we need to find the killer apps that will decide what goes first. And what we're seeing here, we're seeing both of those. We're seeing the emerging standards and the killer apps right in front of us right now. The Ethernet thing, which I'm known for, having invented it in 1973, it was an emerging standard, and it had many competitors, and it took us about 10 years to kill all of the competitors and to emerge as plumbing for the internet. And then there was the question of what the killer apps were, and it's easy to get that wrong. So I founded a company that's tried to sell Ethernet, succeeded eventually, but I remember in the early days people would ask, what good is Ethernet? And I would say, well, it's good for a lot of things. It's universal. It's just carries packets of all kinds. And I learned that customers do not like that answer. Customers don't want to know that your technology can do anything. They want to know what it's going to do for them. Would you like to know the killer apps of the Ethernet?
Yes, please.
PFMTS. Sharing printers, sharing hard disk files, and exchanging email, basically. And we discovered that we could sell Ethernet cards as long as we did those things, as long as we could enable. Now, in those days, fancy printers cost $5 or $10, so they were shareable. And the disks were huge. They were up to 10 megabytes when we started this effort. Then they went to 20 megabytes the year after, thanks to IBM. The IBM PC had these 10 megabyte disks, which we share. Our customers didn't know how to use 10 megabytes, so they wanted to share the 10 megabytes. So we shipped a diskette that would allow you to share a printer, P, share a file, F, and share, I won't go into the rest of it, and share emails. And those were so there was Ethernet, the emergent standard. And then there were the killer apps, the apps for which people would actually pay money. And then Ethernet took off from there. The internet was not the killer app. The internet was years later, and it turned out to be the ultimate killer app, but it took years to get from PFMTS all the way out to the internet that we enjoy today. So my questions are, what are the emerging standards? And I think we saw some demos today of those. And what now the killer app, is the killer app supply chain? Is the killer app some basic security application? What are the hints that we're seeing now as to what the killer apps will be of this trusted artificial intelligent technology?
That's a very good question. I think we're all here to explore that and discover it much as you did. But it looks like there's a lot of excitement, especially around the industry, such as the one that we showcased at the beginning with the Swiss, or generally railways in Europe. Because kind of everybody wants the powers of AI, but there's this sort of gap to jump over. Meaning, how do we put it in an enterprise system, for example, so it doesn't go astray or hallucinate? So it looks like we're very close to figuring out what those killer apps are, and we think there's different ways to use AI as well, like TRAC being one of the most interesting for us, obviously, and one of the most powerful ones. So thank you, Professor, by the way, on that outlook on the history. I'm curious. I wanted to add upon that, touch to that point where basically you said you've seen AI come and go. So what do you think about, what's your view on what's happening now compared to previously? Do you see something different? Like, how do you see AI compared today to its previous attempts?
The principal difference between the previous waves of AI and the current one is the availability of data. So we now have the internet and all of that data there, and for our models to digest. I think a couple of things that have to happen is, one is we need to, and you're leading the way here, is to build the subsequent versions of the AI on top of trusted data, instead of just statistically correlated data, but actual. So 2 + 2 = 4, and I expect that my AI system will answer 4 every single time to that question, and that's not the case now, and that needs to be fixed. And the second thing, which you probably haven't anticipated, a huge breakthrough in the evolution of computing is when we started using computers to advance computers. We came up with compilers, software to develop code to make software. So we got to. So if history is any guide,
It's gone.
AI calling AI, that is building AI on top of AI, having AI ask AI important questions. So the reflexivity, whatever the right word is, we have to get that going. Having AI built on AI in a way computers were, like CAD and compilers, and the use of computers to advance computation.
So that actually flows in very nicely to another question I had for you, which is then back to connectivity. What role does connectivity play in this? Connectivity with real world knowledge and general connectivity, from your experience as the god of connectivity, I would say.
Well, I've been giving a speech about connectivity in the last few months, and the title of my speech is "Connectivity is a Thing." And then I say connectivity is the thing, and then I challenge, is AI more or less important than connectivity? And by the way I reconcile that question is that AI is based on connectivity, and connectivity is now increasingly based on AI. So they're not really competitors there. They need to be leveraged. So for example, the breakthrough technology of today's AI is called neural networks. Well, excuse me, networks is a connectivity term. And so it's based on networks. And so you look at GPT, and what is it? GPT-3, I think, was 176 billion parameters, where parameters are a synonym for synapse, or connections among neurons in the human brain, in the neural network. So the neural networks are themselves a triumph of connectivity. I wonder how many connections will be in the next generation of GPT. And the indicators are that it's, well, one number I have, which is completely made up, is 1.5 trillion parameters or connections. Well, how many connections do we need to achieve AGI? human intelligence. How many do we need? Well, if you look at the human brain, it's got 10 to the 11th neurons. And it's got 10 to the 4, on average, 10 to the 4th synapses or parameters per neuron. So that's 10 to the 11th times 10 to the 4th. That's 10 to the what?
15.
Yes, that's right. Good. Quick. Well, 10 to the 15th is a lot more than a trillion. A trillion is only like 10 to the 12th, right? Isn't it? Is a trillion 10 to the 12th? I always get those mixed up.
Yes.
Well, as big a number as 176 billion is, it's a tiny number compared to the number of connections that we have in the human brain. So in my talk and right now, I'm promoting the idea that the way we're going to make progress in improving the amazing capabilities of our AIs is by increasing their connectivity. And that's their internal connectivity. But then there's another entry point for connectivity in AI, which is the networks in which the AIs exist. So I mentioned that AI requires data, and if it runs out of data, the AIs crash. Sometimes it's called model collapse. The way you avoid model collapse is to be sure that your AIs have access to all the data that they need. So I did a podcast with Jensen Huang of NVIDIA, and he's a great guy, and he was being gentle with me because his company had just chosen not Ethernet for the connection of his GPUs for their next generation. And he was just, being kind to me and broke the news that his company is using something which is not Ethernet. But I reassured Jensen everything was okay and he'd be using Ethernet eventually anyway. The actual answer to that question is if you have a bunch of GPUs, they're connected. Their principal advantage is they're connected together in a very positive way. It's not the PUs that he sells. He sells the G, the graphical. So that is a network appropriate for algorithms related to graphics, and it turns out AI. So the location of these NVIDIA networks depends on what regime you're in. There's the regime on chip, which demands one kind of connectivity, and then there's the demand off chip, where Jensen's going to run right into Ethernet. He's not going to dodge it. He'll be crawling back later as networks. I got to call him. I got to tell him. Elon chose Ethernet for the Cybertruck. The Cybertruck is it's 48 volt gigabit Ethernet is the wiring system of the new Cybertruck. So I think Jensen needs to pay attention to that because his NVIDIA chips are going to be surrounded by Ethernet very soon. Anyway, so I'm making a larger point that connectivity and AI are mutually supportive, and they'll be developing together. And I can't wait to see the 10 to the to get to 10 to the 15th. What's that? Is that peta?
Okay.
Yeah.
Yeah, it is. It is. Yeah.
I guess
Yes,
peta
that's
is kind of short for penta, and penta is short for 5.
Yeah, probably.
1, 5, 15, maybe that's it. Anyway, AGI is waiting for us, and it's waiting for us to get to 10 to the 15th interconnections on a neural net.